Good day, grade 10. This is your revision of chapter 2, day 7. You had to go through the notes of chapter 2 and then you had to do worksheet 7, and this is the memo of worksheet 7. So let's start. The first question is 2x to the power 20 over y to the power negative 6 to the power of 3. When there's a power outside and everything inside is multiplied and divided, then that power on the outside counts for everything inside. So it's 2 to the power 3, x to the power 20 times 3, and y to the power negative 6 times 3. So it's 2 to the power 3, which is 8, x to the power 60, and y to the power negative 18. I don't want a negative power in my answer, so I have to take that y to the top, and it becomes y to the power positive 18. Number 2, 16a to the power 3 over 4a to the power negative 3. 16 divided by 4 is 4, and then when I divide by the same base, I subtract the exponent. So it's a to the power 3 minus negative 3, which is going to be 3 plus 3, so it's going to be 4a to the power of 6. Number 3, 3m to the power 3 over 5n to the power 4 squared. So that squared on the outside counts for everything on the inside. So 3 squared is 9. M to the power 3 times 2 is m to the power 6. 5 squared is 25. And n to the power 4 times 2 is 8. That's all I can do there. Number 4. 2 to the power n plus 1 times 25 to the power n minus 1 times 5 to the power n over 50 times 50 to the power n. First I have to do the prime factors, get the prime factors of each of the bases. To get the prime factor, I can use my calculator. I can use that button that looks like a little point, comma, 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 and shift for that as a fact above. So I put in 25 is equal to shift fact on my calculator, and I get 5 squared if I don't know it by heart. So only the 25 gets substituted by 5 squared in brackets, and the n minus 1 stays outside, times 5 to the power n. Then 50 on the bottom is 2 times 5 squared, and 50 again is 2 times 5 squared to the power of n. So then I get 2 to the power n plus 1, 5 times 5 to the power 2n minus 2 times 5 to the power n over 2 to the power 1, 5 to the power 2, 2 to the power n, 5 to the power 2n. Now I mark all the same bases. All the 2's I mark with one color and all the 5's with another color. Everything that's on top, all the exponents that are on top are multiplied, so I'm going to add them, and everything that's on the bottom will be subtracted because they are divided. So it's going to be n plus 1 minus 1 minus n, then 5 to the power of 2n minus 2 minus 2 minus 2n. So it's 2 to the power 0 times 5 to the power, let's just check that again of the 5's, 2 to 5 to the power 2n minus 2, and then I subtract whatever's on the bottom, minus 2 minus 2n. That gives me 5 to the power negative 4. So 2 to the power 0 is 1, and 5 to the power negative 4 goes to below the line, and that is 1 over 625. Number 5. 6 to the power n minus 2 times 2 to the power x plus 2 over 4 to the power x times 3 to the power x minus 4. First I have to get the prime factors of each base. So 6 is 3 times 2 to the power x minus 2, and 4 is 2 squared to the power of x, and 3 stays the same. So that I highlighted in green, that becomes 3 times 2, and what I highlighted with pink becomes 2 squared. Remember, it's only the base, so I just put the base, whatever I substitute the base with, in brackets. Now we have to see which exponents count for which base. So it's going to be 3 to the power x minus 2 and 2 to the power x minus 2 times 2 to the power x plus 2, and at the bottom 2 to the power 2x times 3 to the power x minus 4. Now I mark the same bases. I have 3's and I have 2's. So everything that's on top gets added, and everything on the bottom subtracted of the exponents. So it's going to be 3 to the power x minus 2 minus, and in brackets, x minus 4. It's important that that part is in brackets. Number 2. And the base 2 is 2 to the power x minus 2 plus x plus 2 minus 2x. Okay, just to get rid of the bracket, it's going to be 3 to the power x minus 2 minus x plus 4 and 2 to the power 0. If I look carefully at number 2's at the base 2's exponents, I see x minus x is 0, minus 2 plus 2 is 0, x plus x minus 2x is 0, so it's 2 to the power 0, and 3 is going to be x minus x, which is 0, and negative 2 plus 4 is 2, so it's going to be 3 to the power of 2 times 1. 3 squared is 9. Number 6. A to the power 3 to the power n plus 1 times ab squared to the power negative 2n over ab to the power of n, that should be in brackets, and b to the power negative 5n. So then I multiply the 3 in, so it's going to be a to the power 3n plus 3. Then that negative 2n counts for the a and for the b, so it's going to be a to the power negative 2n and b to the power negative 4n. At the bottom, I had to have that ab in brackets, so it's a to the power n and b to the power n, and b to the power negative 5n. Now I mark all the a's with one color and all the b's with another color. Everything that are exponents of a on top will be added, and everything on the bottom will be subtracted. So it's going to be a to the power 3n plus 3 minus 2n minus the n on the bottom. Then the b's, negative 4n minus n plus 5n, because it's minus negative 5n, so it's plus 5n. Then the a's will add up to 3, a to the power 3, and b to the power 0. So b to the power 0 is 1, anything to the power 0 is 1. A to the power 3 times 1 is a to the power of 3. Number 7. 15 to the power of m times a squared times 3 to the power 1 minus m over a times 5 to the power m times a times the cube root of negative 27. So now I first have to get prime factors. 15 is 3 times 5 to the power of m times a squared times 3 to the power 1 minus m over a times 5m to the power of m times a times the cube root of negative 27 is negative 3. So that m counts for both the 3 and the 5, so it's going to be 3 to the power m, 5 to the power m. Everything else stays the same. Now, I'm going to mark everything that's the same. I have the same base, so those two have the same base. Then it's going to be 3 to the power m plus 1 minus m. Then I'm going to cancel out a few things. 5 to the power m can cancel out with 5 to the power m at the bottom. Then I have a squared on top and a times a at the bottom, so those can cancel out. I'm only left with negative 3 on the bottom. So, now I add those exponents. 3 to the power m minus m is 0, so it's going to be 3 to the power 1 over negative 3, and that gives me negative 1. Number 8, last one. 3 to the power 2009 times 3 to the power negative 2011 times 6 times 2010 to the power of 0. So when I multiply with the same basis, the exponents get added. So it's going to be 3 to the power 2009 minus 2011 times 6, and 2010 to the power 0 is 1. Just look at that. Only the 2010 becomes 1 because that power 0 only counts for the 2010, not for the 6. So that becomes 6 times 1. 2009 minus 2011 is negative 2. So it's going to be 3 to the power negative 2 times 6. To get that negative 2 positive, I take that whole thing to the bottom. It becomes 6 over 3 to the power 2. That is 6 over 9, and that is 2/3. That's it for the worksheet 7. Please remember, if you have any questions, you can email your teacher. You can find the teacher's email addresses on the web page.